The page appears before you can blink. You tap a link. A white screen flashes. Then the article, the map, the checkout button, and tiny spinner arrive as if they were waiting inside your phone. But your browser did not just fetch a page. It negotiated with the internet, checked an identity, unpacked instructions, built a document, painted a picture, ran a small program, and kept dangerous code inside a controlled room. So what does your browser actually do? Start with the address bar. You type a name like example.com, and it feels like writing a destination on an envelope. But computers do not deliver messages to names. They deliver messages to numbers. So the browser asks the domain name system, or DNS, to translate the human name into a machine address called an IP address. IP means Internet Protocol. It is basically a mailing address for a server on a network. That translation system was shaped in the early 1980s by Paul Machapetris. DNS replaced a fragile older world where machines depended on shared host files, simple lists where each name pointed to a number. That worked when the internet was tiny. It does not work when billions of devices and websites are constantly changing. So before the page begins, your browser has already asked a global naming system a question. Where is this place? Then it opens a connection. If the page uses HTTPS, the S matters. It means the browser is not only talking to a server. It is trying to talk privately and verify that the server is who it claims to be. This happens through TLS, Transport Layer Security. In plain English, TLS is the system that lets your browser and a website agree on secret keys, while strangers on the network see only scrambled noise. This is the first strange truth. Your browser is not just a window. It is a negotiator. It sends a greeting. The server answers. They agree on encryption settings. The server presents a certificate, which is like a signed ID card. Your browser checks whether that ID card was signed by a trusted certificate authority, an organization that helps confirm websites are who they say they are. Only after that does the browser ask for the page. That request usually uses HTTP, the Hypertext Transfer Protocol. Hypertext means linked text. Protocol means agreed rules for how computers talk. HTTP is not the internet itself. It is a shared language on top of the internet, a way for your browser to say, "Give me this resource," and for the server to answer, "Here it is." The modern web grew from Tim Berners-Lee's 1989 proposal at CERN, where the problem was information chaos. Scientists had documents, machines, and systems that did not naturally connect. Berners-Lee imagined a web of linked information, where any document could point to another document, and a simple browser could move through that web. That idea sounds gentle now, almost obvious, but inside it was a radical promise. Any document could become a doorway. Your browser still lives inside that promise every time you click a link. But the page the server sends back is not really a page. Not yet. It is a bundle of instructions. The first instruction set is usually HTML, Hypertext Markup Language. Markup means structure. HTML tells the browser what things are. This is a heading, this is a paragraph, this is an image, this is a button, this is a form. It is not mainly about beauty. It is about meaning. The browser reads that HTML and builds a tree called the DOM, the Document Object Model. A tree sounds abstract, but it is simple. Imagine a family tree for the page. The document sits at the top. Inside it are sections, paragraphs, links, images, and buttons. The browser turns text into a living structure it can inspect, change, and show. Then CSS arrives. CSS means cascading style sheets. Cascading means rules can flow down and override one another. In plain English, CSS tells the browser how the structured page should look. Colors, spacing, fonts, borders, positions, and whether one thing sits beside another or below it. Now the browser has two questions. What is everything? And what should everything look like? To answer them, it combines structure and style into a rendering plan. Render means turn instructions into something visible. The browser decides which things appear, how big they are, where they sit, and in what order they should be painted. This is where the invisible work becomes almost physical. The browser measures text. It calculates boxes. It decides that this paragraph starts here, this button moves down because the font loaded late, and the sticky header stays at the top while the rest of the page scrolls underneath it. Then JavaScript arrives, and the page stops being a document. It becomes a machine. JavaScript was created by Brendan Eich at Netscape in 1995, when websites were starting to need behavior instead of just text and links. JavaScript is code that can run inside the browser. It can open menus, validate forms, play animations, load new data, update shopping carts, and turn a quiet page into an application. That is why your email can run in a tab. That is why a spreadsheet can live inside a website. That is why a map can move when you drag it with your finger. But code from the internet is dangerous by default, so your browser also behaves like a security guard. It runs websites inside boundaries. One important rule is called the same origin policy. Origin means the website identity the browser uses, built from its scheme, host, and port. The rule says code from one origin should not freely read private data from another origin. A random website should not be able to open your banking tab and steal what it sees. Modern browsers add more walls. Chrome, released by Google in 2008, made a major bet on a multi-process architecture. A process is like a separate running container inside your computer. Instead of letting every tab live in one shared space, Chrome pushed tabs and plugins into separate processes, so one crashing page would be less likely to destroy everything, and one compromised page would face more barriers before reaching your machine. That design helped change what people expected from a browser. A browser was no longer just a viewer. It was becoming a small operating system for the web. Then Google's V8 JavaScript engine made that shift feel fast. A JavaScript engine is the part of the browser that reads and runs JavaScript. V8 compiled JavaScript into machine code, the lower-level instructions your computer can execute directly, which helped make web apps feel more like desktop apps. Suddenly, the browser was not only displaying the web, it was executing it. Picture the scene inside your device. One part manages tabs. One part checks certificates. One part talks HTTP. One part parses HTML. One part applies CSS. One part runs JavaScript. One part asks the graphics hardware to compose layers on the screen. Another part stores cookies, cache, history, permissions, passwords, and tiny bits of state that make the web feel continuous. Cookies are small pieces of data a site asks your browser to remember. Cache is saved material, like images or scripts, so the browser does not have to download the same thing again. Permissions are your choices about what a site can touch: camera, microphone, location, notifications. This is why a website can remember your cart. This is why a page loads faster the second time. This is why a weather site can ask where you are. It is also why your browser has become one of the most sensitive pieces of software you own. It knows where you go. It keeps you signed in. It mediates your passwords, your payments, your location, your camera, your microphone, and attention. The counterintuitive twist is that the browser feels simple because it is doing so much. It makes a global network of servers, standards, scripts, certificates, and graphics pipelines feel like one calm rectangle of glass. That illusion is fragile. When DNS fails, the name cannot become an address. When TLS fails, trust breaks before content arrives. When CSS fails, the page looks wrong. When JavaScript fails, the button does nothing. When rendering slows down, the page stutters. When security fails, a harmless-looking tab becomes a doorway for harm. Most of the time, you only notice the browser when it disappoints you. A page hangs. A tab crashes. A password warning appears. A video refuses to load. But every successful page load is a small chain of agreements that did not break. And that is what makes the browser so strange. It is one of the most ordinary tools in your life, but it sits at the crossing point of naming, networking, encryption, documents, programming languages, graphics, memory, identity, privacy, and trust. You open it for news, music, rent, code, learning, symptoms, messages, and midnight rabbit holes. It feels like an app, but it is closer to a checkpoint, a translator, a locked vault, and an operating system. So the next time a page loads instantly, remember what disappeared. The name lookup disappeared. The handshake disappeared. The request disappeared. The parsing disappeared. The layout disappeared. The sandbox disappeared. You did not see the machinery, because the machinery succeeded. The more invisible this machinery becomes, the more power it has over what feels simple. The page appears before you can blink, because your browser quietly rebuilt the world behind it.